So this next chapter that we venture into is going to start talking about proofs, but before we talk about proofs, we have to talk about things that are called statements and conditionals. So a statement is a sentence that can either be true or false. Okay, so the truth value of that statement, again, T for true or F for false, and statements are often represented using letters such as P and Q. So the most common type of statement that you're going to see is a conditional statement. It's an if-then statement. So if P, then Q. Or if we say, if the forecast calls for rain, then I will take an umbrella. So when you identify in a conditional statement, there's two pieces to it. There's a hypothesis and there's a conclusion. And it is all split at where the comma happens. So the two keywords that you have to work with are if and then. So those are the two keywords. But the hypothesis comes after the if. So we're going to underline that once. So that's the hypothesis. And then what occurs because of that is your conclusion, which comes after the then. So I'm going to double underline that, and that's going to be my conclusion. So if you're asked to identify what the hypothesis is, you would say the forecast calls for rain. The conclusion would be that I will take an umbrella. And again, when you identify these, you do not identify or you do not include the if and the then in your hypothesis and conclusion. Those are just linking words that make it into a conditional statement. So many conditional statements are written without using the words if-then. So sometimes you're going to have to write the actual statement itself. So to write the if-then statement, you need to first identify what the hypothesis is and what the conclusion is. So let's just do an example here. So it says, write the following statement as an if-then statement. Points will be deducted from any paper turned in after Thursday's deadline. So you have to read that statement and say, okay, well, where can I break it? At what point can I split that up? So basically, points will be deducted from any paper turned in after Wednesday's deadline. So points will be deducted maybe. So let's see, if we're going to make an if-then statement. So there's a bunch of ways, and it doesn't have to be written in the exact same order that it was originally given to you. So if we basically say, like, if points will be deducted, then any paper turned in after Wednesday's deadline, that doesn't really make sense. So what we're going to do is we're going to flip it a little bit. And we're going to say, if a paper is turned in after Wednesday's deadline, I'm going to abbreviate Wednesday's deadline. So there's my if, comma, then, now what's my conclusion? So what's going to happen because of that? So then points will be deducted. Okay, so when you write these, again, this entire chapter is going to be a lot more writing than we're used to in math. But I should be able to identify and see your if. I should see the word then. I should see commas. And again, I should be able to clearly identify where your hypothesis and your conclusion fall. So remember that the conclusion depends on the hypothesis. So if you turn your paper in late, then your points are going to be taken off. That's the conclusion, or that's the result of what happens. So for the next 4 questions here, we're going to do 2 things. We're going to identify the hypothesis and the conclusion. Hypothesis we're going to underline once, conclusion we're going to underline twice. And then we're going to write an if-then statement. So it says a mammal is a warm-blooded animal. So I'm going to split it after mammal. So mammal is going to be my hypothesis. Warm-blooded animal is going to be my conclusion. And you're going to come up with something. And sometimes there's extra words that you're going to have to add. So you can't just say if mammal. So you can say something like if an animal is a mammal, or if something is a mammal. If an animal is a mammal, comma, then it is a warm-blooded animal. Okay, and you do have flexibility with these, but the key is everybody should be splitting the hypothesis and the conclusion in the same spot. So that's the biggest thing. But just make sure details are there in terms of the if, the comma, and the then with the period. So a prism with bases that are regular polygons is a regular prism. So I'm going to split it after polygons. What comes before that is going to be my hypothesis. What comes after that is going to be my conclusion. So some version of something that you can say could be if you have a prism. If you have a prism with bases that are regular polygons, comma, then it is a regular prism. It is a regular prism. Okay? All right, next one says 4 quarters can be exchanged for $1. So I'm going to split it after 4 quarters. So hypothesis, conclusion. So if you have 4 quarters, then you can exchange them for a $1 bill, $1 bill. Okay, and then the last one, the sum of the measures of 2 supplementary angles is 180. So I'm going to split it at is, because sometimes is sort of equivalent to equals. So that's a good split. So this one we have, so if you have 2 supplementary angles, then the sum is 180. Then the sum is 180 degrees. Okay? Now, the conditional, again, that is your if P then Q. If something, then something. So in order to determine the truth value of it, it would be true in the case that you must be able to show that for every case of the hypothesis being true, the conclusion is also true. But with false, you only need to find one counterexample, only one thing that disproves it in order for the statement to be false. Okay, so a sample would be, it says if you divide an integer by another integer, the result is also an integer. So an integer is a positive or a negative number, and they're whole numbers. Well, this would be false, because a counterexample that you could give would be, all right, well, if I take the 2 integers 1 and 2 and I divide them, well, 1 divided by 2 is a half, which is equal to 0.5, and 0.5 is not an integer. Okay, so it does not equal an integer. So that would be your counterexample that would disprove that piece of information. All right, let's practice a couple more of these, and then I'm going to stop the video and make a second one on the remainder of this. So it says determine the truth value of each conditional statement. If it is false, give a counterexample. So if next month is August, then this month is July. Well, if you go through your months, January, February, March, April, May, June, July, August, July does come before August, so this is true. That will never change. For 2, it says if a triangle has 4 sides, then it's concave. Well, this is certainly false. And we ask ourselves why, and we say, well, a triangle has 3 sides. It does not have 4 sides, and it never will. So that's what makes it false. For number 3, it says angle A is an acute angle. Then angle A is 35 degrees. Well, could it be 35 degrees? Absolutely. But in all cases, no, it does not have to be. So we're going to make this false. And you can just say it could be any number less than 90 degrees, because that is the definition of an acute angle. And for number 4, if we bring the algebra into it, so it says if radical x is equal to -1, then -1 squared is -1. Well, we know this to be false because the square root can never equal a negative number. Okay, so it does not have to be a math type of question with these. It could be anything random.